are two projects. In this video, we are going to explain about a project titled Human Recognition using ear-based deep learning features. This project focuses on utilizing the deep learning features for human recognition based on the ear. The introduction highlights the uniqueness of the ear as a part of the human body, considering the parameters like its outline, appearance, and posture. It also mentioned the increased use of deep learning methods in computer vision. Since datasets containing a large number of ear images are the project aimed to investigate the performance of improvements achieved through deep learning approaches in ear-based recognition. The project also discusses the commonly employed feature extraction techniques in ear-based recognition, including shift invariant feature transform, speed-up robust features, and binary robust invariable scalable key points. The main objective of this project is to investigate the improvement in the performance achieved through the application of deep learning techniques in ear-based recognition. That considering the limited availability of large dataset containing the ear images, the project aimed to develop a hybrid system that combines the deep features with classical machine learning algorithm for classification purpose. To address the limited dataset issue and prevent the overfitting, aggressive data augmentation techniques are employed to increase the number of images. The performance of the system is evaluated using the various metrics such as precision, recall, accuracy, and F1 score calculated from the confusion matrix. This project specifically utilizes the support vector mission as a classifier to predict and robust the regularization property. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is AMI ear database. In this module, the researchers utilize the AMI ear database to extract the ear features. The database consisting of ear images from each person, that of 7 ear images captured from various angles such as front side, back side, and top view, and many more. And the second module is image augmentation. To address the limited number of images per person in the dataset, image augmentation techniques are applied in this module. Since deep learning algorithms typically require a large number of training samples, and the author increases the image count from the 7 to 80 through the augmentation. This process involves generating the multiple copies of each image from different angles, thereby expanding the dataset. And the third module is feature extraction. In this module, a deep learning CNN algorithm is trained on all the ear images. The trained model is capable of capturing the crucial features from the images. The module focuses on extracting these important features from the deep learning model, which will be used for further analysis and classification. And the fourth module is PCA feature selection. Since the deep learning model produces the 256 features, not all of them may be relevant for the classification task. To reduce dimensionality and select the most important features, principal component analysis is applied in this module. This will help identify the features that contribute the most to overall variance in the dataset, thereby reducing the feature space. And the fifth module is training with linear SVM. This feature extracted from the PCA step are then used to train a linear support vector machine model. The SVM algorithm learns from the provided features and creates a trained model. In this module, test data is applied to the SVM model for prediction, and the accuracy is calculated by comparing the test data with the predicted output. The linear SVM approach is used in this module. And the sixth module is of training with quadratic SVM. Similar to that of the previous module, the features extracted from the PCA are trained using the quadratic SVM model in this module. The quadratic SVM algorithm is known to offer improved accuracy compared to the linear SVM approach. The test data is applied to the trained quadratic SVM model for prediction, and the accuracy is calculated by comparing the predicted output with the actual test data. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is here dataset consisting of here images of different persons, and the model folder consists of .h5 files and .npy files, which is used to containing of algorithm information. This file can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making prediction on new data or performing the specific operation. And the test images folder consisting of the images of the different persons, which is used for testing the model. And the augmentation and human recognition are the two Python code files, and this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload AMI Year Dataset. By this, we are importing the Year Dataset folder from this folder and click on Select Folder button. And here we can the screen of dataset is loaded. And click on Image Processing and Normalization button. Here this is used to read all the images and then change all the image size to the equal size and then normalize the image pixel values. And this screen we can see the sample image, whether to check whether the images are loaded properly or not. And now the image is looking good and the condition too. Now close this image. And here the total images found in the dataset is of 800. And then click on Deep Learning Feature Extraction Algorithm button. Here this deep learning model is generated on the pre-processed dataset, giving an accuracy of 99%. And the total features available in this deep learning model is of 19200, and the total important features extracted from the deep learning model is of 256. And then click on Run PCA Feature Selection Algorithm button. Here, by this, the PCA features are pre-processed on this algorithm, and viewing of the dataset is divided into the 640 and 160 as of 80% is for using the training and 20% of the dataset is used for testing. And the total features available before applying the PCA is of 256, and the total features available for deep learning after applying the PCA is of 90. And then click on Run Linear SVM Algorithm button. By this, we get an confusion matrix. Here, x-axis represents the predicted class and the y-axis represents of the test label or the true class. We can see the diagonal of both predicted and test values are matching, and only one image is of wrongly predicted. And now close this confusion matrix. Here the SVM linear algorithm gives an accuracy of 95%, precision of 96, recall of 95, F1 score of 95.54. And then click on Run Quadratic SVM Algorithm button. Here it gives of a confusion matrix where the x-axis represents of predicted class and y-axis represents of true class, and here diagonally we can see of that members. And close this confusion matrix. Here, the SVM quadratic algorithm gives of accuracy 97.5, precision of 98.18, recall of 97.57, and F1 score of 97.7. And click on Recognized Human from Test Image button. Here it redirected to the test images folder. In this we need to select any one of the image from this folder, and I am selecting this image and click on open button. It recognizes it as person 4. In this way we can recognize the human by using the ear features. In conclusion, the project presents a hybrid ear recognition system of deep features and classical machine learning algorithm for classification. The input to the last layer of the feature extraction module in the Inception v3 were used as the feature vector and had a high dimensions of 2048. To make the dimensions feasible for use with the classifier, the dimensionality was reduced using the PCA, and the final dimensions of the reduced feature set with 29 principal components. And the recognition obtained using the linear and quadratic SVM gives an accuracy of more than 90% on the test data. The project concludes that proposed hybrid deep learning classification machine learning model outperforms the existing state-of-the-art methods for ear-based recognition. Thank you for watching.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.